Hey everybody, welcome to this week's installment of video notes for Mr. Flugum's physical science class. Sorry I don't have a song for you this time around, but maybe later this week I'll post another version of this that has a song on it, so tune in later and check that out, I guess. These notes, of course, are on work and power, and they'll go on page 29 in your science notebook. And let's go ahead and get started. Alright, so we got work. All right, you can see the definition of work there, and the key thing is this: work is about transferring energy. So anytime energy is transferred, we can definitely talk about work. If you see that little picture of the lady there lifting that kettlebell, all right, as she lifts it, all right, she applies force to it, and that transfers energy to it as the weight gains height, right? So it's gaining GPE, right? So that means we've got work being done. All right, so one of the things we're going to need to do is we're going to need to calculate work. All right, and work is force times distance. And since work is basically energy, it's transferring energy, right? We're going to use joules as our units. Okay, and I just have a little example problem there of that guy lifting those weights. Okay, 600 newtons, 2 meters. Okay, 600 times 2 gives you 1,200 joules worth of work. All right, so power. That's the other piece of the puzzle that we're talking about. You see power there is the rate at which energy is transferred. In other words, it's how fast are you doing work. Okay, so you can kind of have a scenario where you have two guys that do the same amount of work, but they both do it at a different rate. So that means a different amount of power. Okay, you can see here, both guys, Farmer Smurf and Farmer Ed, they have the same amount of hay bales there, right? Well, Farmer Smurf loaded his hay bales onto that trailer in 45 seconds. Farmer Ed, well, you can see he's maybe a little bit older and slower. He loaded them in 90 seconds. So, who did more work? Or did anybody do more work? And then who used more power? Well, let's flip to the next slide and see what it is. You can see here, calculating power, right? Power is work over time, okay? The units for power, you may have heard of these, are watts, okay? And most of the time we measure light bulbs with watts, and that's because if you have a wattage for a light bulb, that's how fast a light bulb changes electricity into something else, all right? So a 60-watt light bulb and a 120-watt light bulb, well, 120-watt light bulb changes energy at a faster rate. Now, back to that previous slide, okay, where you had Farmer Smurf and Farmer Ed, right? Both load the hay that weighed 900 newtons onto a 1 meter tall trailer. So if we find the work, it's the same amount of work, right? Because they have the same amount of hay, it's 900 joules worth of work, okay? However, Farmer Smurf did his in 45 seconds, so when we find the power, we have 20 watts. Whereas Farmer Ed took much longer, he has less power. Okay, so you can see how the rate at which something is done, okay, is watts, and that means more power. Even though it's the same amount of work, right? It's about how fast the work gets done. All right, here's the things you need to know. You need to be able to calculate work and power. You need to be able to define work and describe what's being done. And the same thing with power, right? Except with power, you need to define kind of what affects power. The big thing there is time, right? And then you also need to use proper units, okay? Joules for work and watts for power. Thanks for tuning in. And like I said, if you want to tune in later, I may update this with a tune or something at the beginning. We'll see if I can come up with something. So, peace out, you guys, and I'll see you in class on Thursday or Friday.